Hello, 7th graders, and welcome back to my YouTube channel. Today we're going to continue our probability unit by talking about the product rule. The product rule is just simply a way to count the particular number of alternatives at each particular stage of an experiment, multiply them together, and voila, you've got the number of possible outcomes. And we're going to just deal with multi-stage experiments here where choice at any alternative does not restrict the number of alternatives at any later stage. That's going to make it relatively easy. So as we see here, we talk about crossing a river. Let's say this river here has 5 different bridges. The next river we come to actually has 3 bridges, and then the next river has those 4 bridges as you see. So following the arrow for the direction of travel. There's 5 different choices you can make for the first bridge. Say we choose bridge number 2 here. Then after we reach the next set, there's 3 different bridges. And on the next river, there's 4 different bridges. So as we can see, that 5 times 3 times 4 gives us 60 different outcomes altogether. That is to say, 60 different ways we could cross these 3 rivers. Flipping a coin, it's even easier because everybody understands when you flip a coin, it's coming up heads or tails. And yeah, so if you're flipping 5 coins, first one can be heads or tails, second one can be heads or tails, and so forth. In this particular path, there were 2 choices, times 2 choices, times 2 ways this could turn out, times 2 ways, times 2 more ways this could turn out. Totals up to 32. Rolling dice, this is an experiment I had you start the unit with. 6 ways times 6 ways times 6 ways, there's that 216 again. Notice how that was a denominator for a number of our probabilities indeed. So in those examples, as you saw, we were making use of simply the product rule. And the product rule again, as I stated at the top of the lesson, the choice at any one stage does not restrict the number of alternatives at a later stage. So like for instance, if we were going back to the crossing the bridge one, if crossing, say, this bridge right here meant that you couldn't choose these 2, now it's no longer product rule. That's what they mean by this in this box right here. It says does not restrict the alternatives available later stages. When the total number of outcomes is the product of the number of alternatives available later. 5-4 uses a decimal die. This is actually an icosahedral dice. They sell these at game stores. Go to Schaumburg, GameWorks, and not GameWorks, but one of the store, I can't think of the name. But they sell dice there that are 20-sided dice. This is an example of one such 20-sided dice, and half the numbers look like this, and then the opposite faces of the die are also numbered 0 through 9. So if that allows us to roll a nice fair die, and if we roll it 5 times, there should give us 100,000 possible outcomes. 10 times 10 times 10, or just simply say 10 to the 5th power. But the product rule can also help us if we have a limited number of other outcomes. So for instance, if I'm only counting odd numbers, well, there's only 5 odd numbers available, 0 through 9. So that'd be 5 to the 5th power, or 3,125. So if we're looking for the prime digits, as the next one describes, prime digits, of course, are going to be 2, 3, 5, 7. So you notice 0 and 1 are not among the primes. So in that case, it's 1,024 different ways that we could, if I was just looking for prime digits. So on the next set here, notice the using of the term ordering right here. The usage of the term ordering is very, very important because I need you to understand that ordering is going to be different from subsets. Later on, we're going to talk about counting the number of subsets of a given set. In this case, I've got 6 items in the set, but I want to know how many ways they can be placed in a given order. Maybe it's a race: 1st place, 2nd place, 3rd place, 4th place, 5th place, 6th place. When that happens, this also uses simple product rule, but the number keeps dropping. So there's 6 places you can put down the first ball or object, whatever that is, and then 5 places for the second one, 4 places left, once you put down first two, there's 4 places left, times 3 places left, times 2 places, and there's only 1 place to put the 6th and final item on our arrangement. And this is going to give us 720 ways of ordering sets. Again, very important you understand we're talking about orders on these sets here. So when you're dealing with subsets, that's going to mean something a little bit different. Oh, no wonder my pen's not working. Sorry for the pause there. Had the eraser on. 720 ways of orderings. Okay, so if I was just going to mention one thing, these are not subsets. Orders, not subsets. So wait, what are subsets? Yeah, I'm getting to those. Just know that we're going to look at something later on and consider how we'd want to be able to count up the subsets. That's going to be a different way of looking at the problem. Now, orderings can be abbreviated. When I had that number here, I actually multiplied out 6 times 5 times 4 times 3 times 2 times 1. When that happens, you can use a little something, a notation we call factorial. That is, when you see this, it's not saying 6 with feeling, but rather it's 6 factorial. So if I ask you to evaluate 4 factorial, say on a coming quiz, you would write 4 times 3 times 2 times 1 and use your math skills to say, yes, that's 24. If you ever encounter 0 factorial, 0 factorial is answerable, but it's not with a 0. We're asking about the number of arrangements of items here. So when I said 6 items, 6 factorial for this one right here, when I said 6 factorial, 6 times 5 times 4 times 3 times 2 times 1 actually gave me 720 ways I can order those things. If I ask for 0 factorial, I'm asking for how many ways can I arrange nothing. The nothing is actually going to be an arrangement, the arrangement of nothing. So I will say 1 for that. So a little special case there, folks. All right, so I want you to work through exercise 50 for today, and we'll come back tomorrow and talk furthermore about the product rule. But for today, you're just doing exercises 47 through 50. Make sure you've got your exercises completed all the way through 36 by tomorrow for when I enter those into the grade book. Thanks for watching and listening. Be good for your parents, and have a great week.